Hi everyone, welcome to HBM Education channel. In this video, let me discuss about sign convention for spherical mirrors. It is very important concept. So please watch complete video here. Now here we have taken two mirrors. In the first case we have taken concave mirror. In the second case we have taken convex mirror. So now here we are going to apply sign convention for spherical mirrors. So spherical mirrors are classified into how many types? Two types, concave mirror and convex mirror. So for sign convention, here we have to take an object here. For suppose, so we have taken object. Let us suppose this is the object. So this is the candle. So we have taken object here. So we have taken an object on the axis. This is principal axis. We know that this is principal axis. This is principal axis. So the object is generally taken on the principal axis. Okay. Now I am going to take a light ray here. So the light ray we have taken. So observe the direction. The light ray is traveling in this direction. So the incident ray, which is, this is what? This is incident ray. This is incident ray. Observe the direction here. Light ray generally traveling in this direction. Means for suppose this is right side, this is left side. Means the light ray, incident ray is traveling from right to left. Means we know very well, already we have discussed the sign convention, the rules of sign convention. In that rule, if you consider in the direction, if you measure the distances in the direction of incident ray, means this side becomes what? Positive. We have to consider positive, because in the direction of incident ray, we are measuring in the direction of incident ray. If you measure in this side, if you measure in this side, means opposite to incident ray going in this direction, we are measuring opposite to incident ray. Opposite means this side becomes negative. Okay, so we have to understand this concept. So observe here, let us take some terms here. We know very well, already have discussed in previous video, that the distance from pole to focus. So the distance from pole to focus, what is this? This is focal length. This is what? Focal length. The distance from pole to focus, the distance from pole to focus is called focal length. Already we have discussed. Now observe here, the distance from pole to center of curvature, the distance from pole to center of curvature is radius of curvature. Okay, now what is this? The distance from pole to object, pole to object, that becomes what? Object distance, u. This distance is called what? Pole to object. This is object, right? So the distance is measured, all the distance measured is from where? Pole. So the distance from pole to object is called object distance. Now let me take, we know very well, when we consider object behind C, we get the image between F and C, between F and C. So let us take, this is image, let us take image. This is, what about this distance? What about this distance? The distance from this distance, the distance from pole to image is called image distance. This is V. The distance from pole to image is called image distance. Now apply the sign convention for the concave mirror. Here if you consider concave mirror, what is R? R means what? Radius of curvature. The distance from pole to center of curvature means which side here? This is negative side, right? So radius of curvature, this radius of curvature generally is measured opposite to incident ray. This is incident ray is going in this direction, we can measure the radius of curvature opposite. So we have to consider this is negative. Okay, directly this is minus. Our radius of curvature is minus or negative for which generally R is negative, because opposite to incident ray. Now take the focal length here. What is focal length? Where the focal length? The distance from pole to focus. The distance from pole to focus we have written here. Means this, which side? This is negative side or positive side? Negative side. So focal length is negative for concave mirror. Now take the object distance. Object distance, where we have taken the object distance here, this is the object distance, right? So the distance from pole to object, the distance from pole to object is nothing but object distance. So object distance is negative side or positive side? So negative side. So if you observe here, u is in the negative side, so we have to consider negative. Object distance is negative. What about the image distance here? Here if you observe the image is generally we observe that the image formation taking place in this side, means negative side. Okay, so negative side means we have to observe here object distance is negative. But in the ray diagram, there are 6 ray diagram for concave mirror. In those 6 diagram, one image formation takes place in the mirror, so this distance is this image distance is positive in one of the case. Okay, so this is virtual image and these are all the real images. So for virtual image, the distance becomes what? Positive. And if you observe this image, the inverted image, or we can say this image distance is negative. Means in the 4 cases, in the ray diagram, 6 ray diagrams are there. In 4 cases, the distances, the image formation takes place in the negative side, and in one case image formation takes place at this virtual side. So observe here, V is positive or negative. Remember this one, means images may be formed in this side and some only one image forms at the virtual side. So observe next height of the image. Let us apply sign convention for the height of the image. Observe here height of the image. If you observe, image is down, image is inverted, means downward to the principal axis. Image is formed downward to the principal axis, means inverted image here. If you observe, this is image, right? This is also image. In one case, image is virtual, means in the concave mirror, the image formation takes place erect images you will get, and in one case, in all the 5 cases you will get, out of 5 cases you will get 4 cases you will get inverted images. You will get inverted images and you will get erect images in the concave mirror. So observe here, height of the image is whether inverted means what, you have to take minus, and in one case you will get erect image. So positive or negative you have to write. Now height of the object. Remember that object we can consider object always, the candle, we have to take candle always erect position. So here if you observe, height of the object is always positive, means we have to consider object always upward to the principal axis. Upward to the principal axis we have to take positive, downward to the principal axis we have to negative, means always remember height of the object is positive in both cases. So let me discuss about sign convention for convex mirror here. So let us discuss the terms here. So we know very well the distance from pole to focus is focal length. The distance from pole to center of curvature, the distance from pole to center of curvature is radius of curvature. Now let us take an object on the principal axis. This is principal axis. Okay, so let us take an object on the principal axis here. So we have taken an object on the principal axis. I am going to take a light ray here. This is incident ray. This is incident ray or incident light. So if you observe the direction here, our incident ray is going from right to left. So if you follow the direction of incident ray, you should take this side as positive. If you measured opposite to incident ray going in this direction, if you measured opposite to incident ray in this direction, if you measured opposite, then you should consider this side as negative. Okay, so now we have taken object, this is object, so this distance becomes u. What about the image formation takes place here when you consider object on the principal axis? Already we have discussed the ray diagram for convex mirror. that whenever the object is kept in front of the convex mirror, the image formation takes place between pole and focus. The image formation here, the image is formed at this distance. So this is image, so this image distance is V. Now apply the sign convention here. You have to observe whether this is negative side or positive side. Then you have to apply sign convention. Where is R? R is at which side? Positive side. Means you have to write plus. Okay. Simply you can determine whether positive or negative. F. What is F? F means focal length. Which side this is? Which side? Positive. So you have to remember plus. Focal length is positive in the case of convex mirror. U. What about the U here? U is in which side? Negative side. So you have to write negative. Okay. Next, what about the V? Observe here, in the case of convex mirror, only one ray diagram is possible. So that ray diagram is virtual or erect. The means virtual or real. That is virtual image. Means inside. So image formation takes place behind the mirror. So this is virtual image. So virtual image is always erect. Okay. So observe here, height of the image distance. Let me observe. So V is positive side or negative side? Positive. Only positive is possible. Now observe the height of the object. What about the height of the object? Height means this is object, right? We have taken this is the object. This is the object. What about the height of the object? This is HO. This is what? HO. If you observe here, object is erect. Erect means like this, upward to the principal axis. Means this is what? Erect. Okay. So always remember, object always kept upward to the principal axis. Means if you measured upward to the principal axis, we should consider as positive. Simply you can write height of the object always positive in concave mirror and convex mirror. Now in the case of height of the image, observe here, this is image, right? So this is image. We have written height of the image means HI. Principal axis, upward to the principal axis or downward to the principal axis? Upward to the principal axis. Upward to the principal axis means directly you may write positive. So these are all the sign convention we have applied. So based on the rules of sign convention, we have applied sign convention for concave mirror and convex mirror. So thank you very much for watching this video. Please do like and subscribe this channel. Thank you very much.